But uncoupling in mitochondria basically means uncoupling oxidative respiration, burning of fuel, from producing ATP. And it's been known about since the 1970s. And so I use a kind of a fun analogy in the book about the mito club and the electron transport chain in mitochondria. But I'll stop there because we'll get back to that.
This is already so fascinating because this is turning it on its head because you just said the thing. We want to turn you into an efficient fuel burning machine, of an efficient fat burning machine. And now, but I love this analogy, and I know you got to use this more often and flesh this out as you talk with more folks. We're exclusive, by the way. I got the book early. I might have got one of the first copies, and also this is one of the first times that you're actually talking about this on a big platform. So folks, really listen in closely. When you gave this analogy with being a Prius or Ferrari, if we use that as an analogy for the bodies that we want, it's just like I'm trying to have that, I want a Prius hump on my shoulders versus being something sleek and fast and dynamic and attractive. You're actually inefficient at burning fuel. You're, quote, wasting a lot more of the fuel that you're taking in due to this mitochondrial uncoupling phenomenon taking place. And so there's this really sneaky thing because the researchers in that study you mentioned, they said that the twin who was overweight or obese had, quote, lazy mitochondria. And you also mentioned this earlier too. We've got different pathways. We got with the mitochondria, we've got beta oxidation, we've got cellular respiration. It's not just this one thing. And we tend to think like we got to give the mitochondria this particular thing, but we're kind of missing the point because here's where we talk about ketones. This is the role that ketones actually play in this mitochondrial uncoupling. Let's talk about that.
All right. So let's, first of all, try to accept that what I've said so far is true. I can assure you I don't make this stuff up, and it is backed up with really great research that I didn't do. So I'm trying to figure out, well, wait a minute. Ketones are produced primarily when you're starving to death. And yes, they're a great way to keep your brain, online while you're waiting for your next meal. They're produced during a ketogenic diet, and they're produced under extreme exercise. But if ketones, in fact, are telling mitochondria who are starving to death to waste fuel, you go, wait a minute, that makes absolutely no sense. If I was designing an organism and there's no fuel, there's no food coming in, I'd want to design my mitochondria to hold on to every last ounce of calorie to become profoundly efficient at turning those calories into energy. Because, if they don't, I'm dead. But then there's an obscure paper that just twisted my brain and just spat it out by Martin Brand in the year 2000. And it's a very simple title. Anybody can Google it. It's called Uncoupling to Survive. And he said, and the proof is actually in the pudding, if you're starving to death, ketones should instruct mitochondria to protect themselves at all costs. Because without mitochondria, we won't exist. They are our power plants. So ketones instruct mitochondria, rather than becoming efficient, to number one, waste fuel, because making ATP is really damaging to mitochondria, and I go into why this is. Producing energy is hard work, and it damages our mitochondria. So as strange as it seems, if you want to keep your mitochondria in as good a shape as possible, you don't want them to do much work. So ketones tell mitochondria to waste fuel. That means uncouple. Number two, simultaneously, ketones, which are signaling molecules, tell mitochondria to make more of themselves. And that's called mitogenesis. And the cool thing about mitochondria is that mitochondria have their own DNA. And so they can actually make lots of mitochondria within a single cell without the cell dividing. And so ketones actually tell mitochondria, okay, each of you don't work so hard, but I want you to get 5 of your buddies online so that the 5 of you now, each of you don't have to work as hard, but the 5 of you now will make as much energy as the one guy did before. So it's like, having 5 horses on a sled rather than 1 horse on a sled. The horses have to do less work. Number 3, what ketones do is tell the mitochondria to repair any damage, because we've got to keep you guys pristine, because we don't know when we're ever going to get something to eat again, and protect yourself at all costs. So in this simple paper, Brand said this is actually why ketones work, and it's exactly the opposite of why anybody thinks it is. Now, what he's subsequently done, and here's the kicker, if you look at super old people or super successful healthy animals, they have the most uncoupled mitochondria. You look at 105-year-old people, they have the most uncoupled mitochondria compared to anybody else. So now you go, wow, I kind of like to uncouple my mitochondria. Are there other ways to do this? And that's the purpose of unlocking the keto code, because it turns out there's a whole bunch of easy, cool ways to do it.
This is phenomenal. Phenomenal. So we're activating the creation of more mitochondria, right? We are
Yep.
creating a situation where we're repairing our mitochondria, which again, you said they're getting damaged in this process. Basically, it's a good analogy of they're doing a workout but not getting a chance to heal, in a
That's
sense.
exactly right. That's
You
exactly
know,
right. And in a way, the more you actually make them do a hard workout, the more damage they do. And you and I both know, me and you probably by experience, if you don't have rest and repair days, and LeBron is a perfect example of this right now, if you don't have rest and repair days, I got news for you. The damage will rapidly show itself, right, in one way or another. And so we know this now about mitochondria. And if you like the mitochondrial theory of aging, which I like a lot, then your mitochondria, keeping them in tip-top shape, is really one of the keys to successful aging.
I love this. So, our mitochondria are very special. This is a big part of us being the humans that we are, is thanks to these little remarkable organelles. Let's talk more about them. How many mitochondria do we have? Like, how many do we have in our cells? How many do we have in general?
Well, this is kind of fun because most of us in high school biology, you'd see a picture of a cell and there'd be a mitochondria, which kind of almost looked like a radiator. Mitochondria are engulfed bacteria, from what we can tell, that were engulfed uh, 2 billion years ago, that made eukaryotic cells. And mitochondria, in exchange for food and a place to live, generated copious amounts of ATP for the cell. To give you an example that I talk about later in the book, there's really essentially 2 ways to generate energy from sugar or other things. One's glycolysis, which most of us know as fermentation. So for every molecule of glucose, you get 2 molecules of ATP from glycolysis or fermentation. A mitochondria can take that same molecule of glucose and make 32 molecules of ATP. Now, talk about a return on investment. But in exchange for being that just powerhouse of converting calories into energy, damage is done 24 hours a day. And that damage really rapidly adds up. Now, we have some damage control systems that I talk about. I call them bouncers in the Mito Club. And the Mito Club is the hippest, hottest place to be. So it's where all the 20 somethings and some of the millennials are trying to get into. And the Mito Club is what's called the electron transport chain, where we take sugar or fats and convert them into ATP. And this process is it's hot, it's steamy, and you got all these protons and electrons and oxygen molecules pushing and shoving, wanting to couple up to produce energy. And that's where the word coupling comes from. And people are drunk, people are horny, their hormones are flying. And so there's bouncers in these clubs to kind of put the lid on everything. And it turns out there's only two bouncers in mitochondria, despite what everybody has been convinced of. And they are melatonin and glutathione. They are the only two mitochondrial antioxidants. This idea that we ought to swallow antioxidants and they're going to help our mitochondria is so old and incorrect, it's amazing. So there's only two bouncers in the club, melatonin and glutathione. And we'll talk about melatonin if time permits, because it's not a sleep hormone, folks. And you sleep, not to go to sleep, but you sleep to produce melatonin to repair your mitochondria. And it's so cool, it's amazing.
This is remarkable. Like we absolutely must talk about this, these bouncers a little bit more. And so within the context, so this cellular club atmosphere, do we have like 100 of them in our cells or like?
Oh, yeah. Yeah. So we actually, some of our cells, like muscle cells, brain cells, have thousands of mitochondria in individual cells. Some cells have very few, but the real guys who need power have thousands of mitochondria. So it's nothing like what we see in our picture books. In fact, a lot of people have heard about brown fat. And I go into this extensively. There's brown fat, there's white fat, which is our main storage fat, and then there's beige fat. And that beige fat is white fat that's being transformed into brown fat. Now, brown fat gets its name from the fact that it is so packed to the gills with mitochondria that it actually looks brown under the microscope. And that gets me to my second point. Brown fat produces heat. And we've known that for years that, for instance, hibernating animals produce heat from their brown fat. They make heat by uncoupling mitochondria. And it's the release of some of these agents, like extra protons, from making ATP that actually produces heat. And fun fact, you and I sitting here right now, 30% of everything that's heading into our mitochondria is uncoupled from making ATP. 30% of the calories at rest. And that's because in the process of wasting these calories, we actually produce heat as the process of wasting calories. And to go back to the club analogy, for instance, so it's hot and steamy in there. There's fights breaking out. There's a lot of coupling that's going on that shouldn't be going on. There's a lot of guys, let's call them protons, who are missing out on coupling with oxygen. And eventually a lot of these protons get pissed off. And they go, I'm out of here. I'm going to go down to a club down the street. Unfortunately, normally the way our mitochondria work, there's one door in and one door out. And the door out is the way we generate ATP. It's literally a revolving door. But we have built into our mitochondria emergency exits, and they're controlled by uncoupling proteins. Now, there's 5 of them that were discovered in the 70s. And what happens is, if things get pretty crazy, these protons push the emergency exits out open, and they go, I'm out of here. And it feels good to breathe again. I'm heading down to the next club. I'm tired of this club. And so it's opening up these emergency exits that it's what actually ketones do to our mitochondria. And it's really fascinating how beautifully designed this was if we just pay attention to how the design works.
Yes, man. You know, the uncoupling protein one, for example, and again, you just mentioned we got five, but this reminded me of some research that I saw. This has been a couple of years ago now. This study was using MRI technology, fMRIs, and looking
Yeah,
at the parts of the
functional MRIs.
body that were lighting up based on different substances that they were giving test subjects. And they found that when folks were drinking coffee, brown adipose tissue sites on the body were lighting up. And they were linking this to something happening with uncoupling protein 1. And
Yep,
so, as you mentioned, brown fat being so dense in mitochondria, it gives this brown appearance. And, even though they they could be considered essentially weightless, we have so many mitochondria that it actually makes up a notable amount of our biomass as a species.
correct, correct.
But here's the rub: our brown fat ratio is not that high, especially in adulthood for the average American. That's the key for the average American because that ratio can be influenced by our lifestyle. And this is another kind of powerhouse opportunity for us to not necessarily, again, we're burning more energy in the old mindset, but we're wasting energy. We're kicking off energy through this process of thermogenesis by our mitochondria being able to do this magical work, and ketones play a big role in this. So let's link this together now with you've touched on a few things on how we can influence this process, but I think there's one more critical building ingredient, which is the role that our microbiome plays in this. Because you said that our mitochondria itself or themselves are essentially bacteria that have integrated with our quote human tissues or human cells, and we've created this kind of symbiotic relationship through our evolution. Now there's so much science being dedicated to our microbiome, and it's just like all of this is linking together, and you're really helping us to flesh this out. So let's talk about how our microbiome and mitochondria are tethered together.
Yeah, so these literally, it's the sisterhood, as I call them. So we actually inherit all of our mitochondrial DNA from our mother, and we don't get anything from our father. Sorry, guys. And we actually inherit all of our microbiome initially from our mother. Our mother basically takes a crap on us on the way out, and many of you have been suspicious of this, and I can confirm it. And so our mother actually seeds us with her mitochondria genome and her microbiome. And so they literally are linked. And for years, we were very suspicious that the microbiome talked to the mitochondria because they literally were sisters. And for years, it was postulated. And a professor from Paris, Marvin Eddes, who I talk about in the book, years ago used to tell me that number one, anyone who thinks polyphenols are antioxidants, just, I don't have any time for you. It's not true. And number two, he was the first one to tell me, he said, look, the microbiome talks to mitochondria. They control mitochondria. And I go, well, why haven't we discovered these? He said, just trust me, we will. Well, he was right. The first postbiotic was nitric oxide, and it got the Nobel Prize. And nitric oxide originally was discovered from the microbiome. We now know that there are a ton of a language that the microbiome talks to the mitochondria. And I profiled this in the last book, and I bring it back in this book. And they're called postbiotics. They're either called gaso-messengers or gaso-transmitters. And your microbiome has to have prebiotic fiber, soluble prebiotic fiber, to eat. And in the process of eating this fiber, the microbiome transforms this into these postbiotic gaso-messengers. And one of the coolest of them is butyrate. So butyrate, butyric acid. Butyrate just happens to be a mitochondrial uncoupler in its own right, but butyrate is actually a substrate for beta hydroxybutyrate, and anybody in the ketone world knows about BHB, which is beta hydroxybutyrate. And so the more butyrate you can produce, believe it or not, the longer you live, the healthier you are. And as I talk about in a sidebar in the book, butyrate and other of these short chain fatty acids are actually incredible cancer suppressors. And they're called histone deacetylase inhibitors, and it's okay, don't worry about it. But these things actually prevent cancer cells from growing and dividing. And so butyrate is really good. Number two, there's another short chain fatty acid that almost everybody's heard of, but has no idea why it's so important, and that is vinegar, acetic acid. Vinegar is another short chain fatty acid as a product of fermentation. And this goes on in our gut all the time, but it also goes on in fermented foods. And as I point out in the book, fermented foods have nothing to do with you eating healthy probiotics in the fermented foods, but everything to do with the fact that you're eating a short chain fatty acid, acetic acid, that, oh, by the way, uncouples your mitochondria just like ketones do. So, surprise, surprise, the benefit of apple cider vinegar or balsamic vinegar isn't some magical, mystical thing. It's actually uncoupling mitochondria. And since you brought it up, coffee contains polyphenols, and we'll do that next. But the reason most of us get a warm feeling when we have a cup of coffee, even an iced coffee, is because the caffeine and the polyphenols in the coffee are both major mitochondrial uncouplers, and they do so in brown fat, among other things. And that's why the brown fat lit up on the functional MRI.
More amazing episodes just like this one. Watch now. Take your olive oil, mix in some MCT oil, and then use your dressing, apple cider vinegar, balsamic vinegar, and use that on your dressing, on your salads.